The new topic for the session is direct and inverse proportion. So what is a direct and inverse proportion? So before we start the mathematical part of each of the content and its definition and varied properties, let me come with a real life example as an introduction to this topic. So for example, I'm not a good cook, but if I just use 4 cups of water in making 2 cups of rice, say for example, I use 4 cups water plus 2 cups rice to make a food for 3 persons. So generally, if I want to make the food for 3 members of a family, I take 4 cups of water plus 2 cups of rice, then I cook, then I get the food for 3 persons, which I do it on an everyday basis. But one fine day, suddenly there have been 3 more guests who have come to the house. So with 3 guests more, I was puzzled to know how many cups of water and how many cups of rice I need to use to cook exactly for 3 original persons already in the family plus 3 more guests, that is to cook the food for 6 persons. With 3 in the family and 3 in general for the guests who have been invited to the house. So in case of this real life problem, then I have to think of direct and inverse proportion of the contents of mathematics. So in case of this, I clearly understand that more the number of persons, more is the food I need to make, which is directly the proportion, which is the direct proportion. More the number of persons in the house, more the food, more the quantity of food I need to make. So the quantity of the food and the number of persons inside the house is what are directly related. So in case of this, clearly I understand that because for 3 persons, I use 4 cups water plus 2 cups rice to cook the food exactly for 3 persons. Then with 3 more persons, I have 4 plus 4 cups of water, because 3 for the family and 3 for the guests. And I have 2 plus 2 cups of rice, 3 for the family and 3 for the guests, the 3 guests more who have come into the family as invited. Then exactly I can make the food for 6 persons, 3 of the family and 3 of the guests. So this is how I understand, which gives me the answer 8 cups of water plus 4 cups of rice, which gives me food for 6 persons. So if I have 9 persons, 3 more guests have arrived in addition to already the 3 guests who have arrived. Then totally for 9 persons inside the house, I have 4 plus 4 plus 4 cups of water, 2 plus 2 plus 2 cups of rice, which exactly makes the food for 9 persons. So mathematically, this is how I construct the number of the food which can be available ready for the number of persons, which directly depends on the number of persons who have come. So here I identify that the quantity of food I prepare, is directly proportional to the number of persons who are estimated, to the number of persons in the house. So this is how I directly relate between the quantity of food and the number of persons. So mathematically, the direct proportion is when one quantity is increased, the other quantity is increased. When one quantity is decreased, the other quantity is decreased. In case of this example, when number of persons are more is the quantity of food I need to prepare. When less is the number of persons, less is the quantity of food I prepare for the family and the guests. So this is how I directly and inversely relate. Now, let's take an example of a real life problem where we can differentiate between the direct and the inverse proportion. So let me take an example where I study at home, I get good marks. The more I study at home, the better are the marks I get because I improve on how much I study at home. Practice. Practice is what is required for mathematics. The key to success in mathematics is practice, practice, and practice. Therefore, I study at home, I get good marks. When I play at home, I get less marks. So I want to take the same example of the student studying at home and the marks related to what he's getting in the exam with direct and inverse proportion. Let me take this as example 1 and this as example 2, where I study at home, I get better marks or good marks. I play at home, I get less marks. In case of this, the more I study at home, the higher are the marks I obtain, which are directly related. The more I study at home, the more are the better marks, or the number of marks which I get is more good or better. So the more I study at home, the better are the marks I get, which are directly related. But the more I play at home, the less are the marks which I get, which are inversely related. So studying at home is directly related to the marks I obtain in the exam. Playing at home is inversely related to the marks I obtain in my examination. Of course, there's no restriction that I shouldn't play at home, but the more I play at home, lesser are the marks, is how I relate the inverse proportion. The more I study at home, the better are the marks I obtain, is how I relate with direct proportion. So my first example relates to direct proportion of the quantities studying and getting marks. And my example 2 relates to inverse proportion, simply because here more I study at home, more are the marks. More I play at home, less are the marks. So this is how they are inversely related when I take the two different situations of studying at home and playing at home. Therefore, the quantities when taken in real life will decide on whether the given quantities are directly or inversely proported. And this identification of direct and inverse proportion strictly depends on the situation of the real life problem. The two examples being more better to understand the direct and inverse proportion. So now that we have taken the real life examples where I could judge between the quantities being directly proportional and the quantities being inversely proportional with the example problem as taken for studying at home and getting the marks and playing at home and getting the marks. So let's directly enter into understanding the definition of direct proportion and its varied properties. So independently, I would study the direct proportion out here. So let's write the definition. So with the definition, the quantities x and y are said to be directly proportional if I understand mathematically that when x increases, y equally increases at the same time, and when x decreases, y equally decreases at the same time. With either of these cases, I understand that the two quantities are directly proportional. For example, number of persons at home, if this is x, and quantity of food made for them is y, as I taken in the previous case. More the number of persons at home, more is the quantity of food I need to make for them. So x increases, then y has to increase. Therefore, increase of x implies increase of y, and decrease of x implies decrease of y, because less are the number of persons in the house, then less is the quantity of food I need to make for them, which has already been taken as an introduction example problem. So this can be taken as a perfect example for understanding the direct proportion as a real life example. So mathematically, the definition says that the quantities x and y are said to be directly proportional if x increases implies y increases, and if x decreases implies y decreases. And the symbol I use for directly proportional is the notation directly proportional is denoted by this. So this is how I denote the directly proportional. That is, when I say x is directly proportional to y, implies x is directly proportional to y, is how I understood with the symbol directly proportional. And mathematically, this is very important, because we say that when two quantities are directly proportional, their ratio is constant. So mathematically, we understand that when two quantities are directly proportional, their quantities are in constant ratio. This is very important in mathematics, because we identify that when two quantities are directly proportional, their quantities are said to be in constant ratio. Therefore, mathematically, we have the concept, the law of nature, which says that when two quantities are directly proportional, they are said to be in constant ratio. That is, when I have x is directly proportional to y, as denoted with the symbol directly proportional, the two quantities x and y are directly proportional. That is, the quantity x is directly proportional to quantity y, implies the ratio must be constant. So when I take the quantities in ratio, that implies x by v must be a constant ratio. So this must be a constant ratio. Therefore, when I say this is a constant ratio, let me call that constant ratio as, say, some constant k. So in this case, my mathematical relation, when I have x directly proportional to y, indirectly makes me understand that x by y is equal to some constant k, where this is a constant. Or I can also write this as x equal to k times of y, which I understand indirectly as directly proportional. Therefore, x directly proportional to y implies x is equal to k times y. This is how I understand the direct proportion in mathematical concept. So x directly proportional to y implies x equal to ky is how I understand the relation between the direct proportion and its respective equation in quantities form. So where k is called constant of proportionality, in this case k is called constant of proportionality. So for direct proportion, k is called the constant of proportionality, and then this is how I relate mathematically the direct proportion. So now that we understood the direct proportion concept mathematically, where, to recap from the previous session, x is directly proportional to y implies x by y is a constant ratio. For the quantity x and quantity y being directly proportional, the ratio of the quantities must be always a constant ratio. So taking this into consideration, let's see if x1 relates to quantity y1 and x2 relates to quantity y2 in case of the quantities x and y. So if this relates to y1 and this relates to quantity x y2, then in this case I have the two quantities in same ratio. Therefore, using the property that the two constants are in same ratio, therefore I get x1 by y1 must be a constant ratio even equal to x2 by y2. Because the two ratios are constant, both of them indirectly must be equal. Therefore, I have x directly proportional to y also gives me the property that x1 by y1 equal to x2 by y2, which I understand as the mathematical property when two quantities are involved with those respective quantities. So when x is directly proportional to y, the subcontents x1 by y1 must be equal to x2 by y2, which is equal to k, the constant of proportionality. The value as obtained from this and this will be a value which is called constant of proportionality, which is denoted with k. So this is how I understand for two quantities. If I have three quantities, then I have x1 by y1 equal to x2 by y2 equal to x3 by y3, so on and so forth till xn by yn for n different quantities respectively proportional to each other. So is how I understand this. Now how do I apply this in real life is the biggest question out here. So what is the application of direct proportion in real life? So let's take an example problem where we understand how direct proportion is related to the real life daily mathematics. If the cost of 15 books is, so in this case let's take this example where the question says if the cost of 15 books is rupees 1200 or 1200, then what is the cost of 24 books is my question. So let's connect this to the direct proportion. Now as I understand here, the cost of books is one quantity and the number of books and the number of books is another quantity. So identify that there are two quantities which I identify in case of this problem. So whenever a problem is given in a direct proportion or an inverse proportion, firstly identifying the quantities is very important. The first step is about identifying the quantities in the real life situation of the example problems. So in this example problem, I understand the quantities. There are two quantities, one being the number of books and the cost of books. So the quantities in case of this problem I identify as the number of books and the cost of books. So this I take it as x and this I take it as quantity y. So my quantity x is related to number of books and my quantity y is related to cost of books are the two quantities which I identify in case of this example problem considered. Now here it's clearly said that the cost of 15 books is 1200 rupees, then I want to know the cost of 24 books. Clearly I understand the direct proportion between the two quantities. I need to justify the two quantities for its direct proportion or inverse proportion through understanding in real life situation. Now as I understand in this case, as the number of books increase, obviously the cost of the books also increase because each of the book would have an added cost. Therefore, the number of books increased implies cost of books increases. Number of books decreased implies cost of the books decreases is clearly the direct proportion as seen in the previous case. So clearly, number of books is directly proportional to cost of books, because the number of books increased implies the cost of the number of books considered increases, but the number of books reduced will reduce the cost of books, which can be clearly understood through the real life situation. That implies the quantity, that implies x, which is the number of books, is directly proportional to the cost of books. Therefore, the direct proportion relating to understanding that the ratio must be a constant. the constant of proportionality k. So with this understanding that the two quantities are directly proportional makes me understand indirectly that mathematically x directly proportional to y implies x by y equal to k. So therefore, let's come back to the question where 15 books, the cost is 1200 rupees. So 24 books, the cost is how much? Is how I understand the question. So to find this, I just relate them with the constant ratio because this quantity is directly related to this and this quantity must be directly related to this. So as we have taken in the previous case, when x1 is directly related to proportional to y1 and x2 is directly proportional to y2 or related to y2, then in case of direct proportion, I have that x1 by y1 must be equal to x2 by y2. So using this concept here, if I take this as x1, then x1 by y1 must be equal to x2 by y2, where I have taken x1 as 15. So I get my x1 as 15 and my y1 as 1200, and that is equal to my second quantity x2 is related to y2. So 24 must be related to y2 is what I need to find. The cost of 24 books is y2, which I need to find. When I compare this with x1 related to y1 and x2 related to y2, then x1 by y1 must be equal to x1 by y1 must be equal to x2 by y2. So 15 divided by 1200 must be equal to 24 divided by y2, which I need to find using this formula. So in this case, when I cross multiply them, I get 15 times of y2 is 24 times 1200, so that this, on taking the unknown y2 on the left side and the rest of the constants on the other side, I get 24 times 1200 by 15, which on simplification gives 3 5s, 3 8s, 5 1s, 5 2s are 10, 5 4s are 240, which gives me the value on multiplying as 240 times 8, 8 4s, 32, 8 2 16, 1920. Therefore, the cost of 24 books is rupees 1920 is how I understand this problem through the direct proportion. Therefore, the question being that what is the cost of 24 books, my answer would be, therefore, the cost of 24 books is rupees 1920 is the answer which I obtained by using the direct proportion concept, the formula which we have derived for direct proportion, x1 by y1 equal to x2 by y2. So let's go with the inverse proportion, as we already discussed in the introduction part through some real life examples. Let's come with understanding the mathematical varied properties of inverse proportion. So when it comes to inverse proportion, as we compare with the direct proportion, in case of direct proportion, the definition says that when x increases, y must increase, or when x decreases, y must decrease. So when you go with inverse proportion, it is quite opposite to the definition as seen in direct proportions. Therefore, in case of inverse proportion, we identify the definition that when x increases, y decreases, and when x decreases, y increases. The opposite of increasing and decreasing concept is what differs between the direct proportion and the inverse proportion. So let's take an example problem or a real life example through which we understand inverse proportion more better mathematically and algebraically or in general. So when it comes to inverse proportion, let x be the number of workers working in a construction company. For y hours. So let me say there are x number of persons or number of workers working in a construction company and they are working for y hours. So as I understand in the case of this real life problem that if there are more number of persons working, we understand through our general means that the work will be completed very fast. If there are less number of people, then we understand that it takes more time to complete the work. because less number of people will have more of manhandling or more of the work to handle with more responsibilities. Therefore, in case of this real life problem, I understand that more the number of workers working in a construction company, less is the time taken by the workers in completing the work. So less is the number of workers, I understand more is the time taken by the workers to work in the construction company. So because one of them increased reduces the other quantity and one of them reduced increases the other quantity, I clearly understand this real life example as an example of inverse proportion. So when I take the quantities here, I have number of workers working in the construction company and the time taken by them in completing the work, the given task. So here the number of workers, let me take it as X, and time taken, let me take it as Y, assumed in hours. So in case of these quantities, I identify the quantity X as number of workers, the other quantity Y as time taken in hours. So therefore, I understand here that when X increases implies Y decreases, because when the number of workers increase, they complete the work in less span of time. When the number of workers is less, they take more time to complete the given task in the construction company. So when X increases implies Y decreases, and Y decreases implies Y increases. Therefore, the quantities X and Y are in inverse proportion, are inversely related. So this is how I understand the inverse proportion through the real life example. But mathematically, as in case of direct proportion, we say that X is in inverse proportion to Y clearly implies that this is how I understand the inverse proportion, because when X decreases, Y increases, and when X increases, Y decreases, they are reciprocal of each other in direct proportion. So when X is inversely is in inverse proportion to Y, I understand this through X inversely proportional to Y indirectly. So this is how I understand inverse proportion mathematically. But as I see this, I can say that when X is directly proportional to Y, when X is ky, so they differ by a constant of proportionality which comes into existence. Because when X is directly proportional to Y, then X can be written as k times of Y, as we have already derived in the previous session. Therefore, X directly proportional to 1 by Y or X inversely proportional to Y is how I read this. Then this will be k times of Y, where k is constant of proportionality. So this is called constant of proportionality. So therefore, when X is inversely proportional to Y implies X equal to k by Y or xy is equal to k, is how I understand the inverse proportion in the notation. But one thing is very important here, that this is read as X is directly proportional to 1 by Y and equally read as X is inversely proportional to Y. So 1 by Y is how I differ between the direct and inverse proportion, but mathematically understood in this form. And here I understand the definition through increase implies decrease, decrease implies increase in inverse proportion. And in direct proportion, increase implies increase, decrease implies decrease of the two quantities in direct proportion.